Hi everyone. Our objective for this video is to look a little bit more deeply into the parabola. So in class we were able to derive the definition of a parabola and also the equation in standard form. So this is the equation we came up with more or less. And remember, P is our distance from the focus and the directrix. Okay, specifically how far the focus and directrix are from the vertex of the parabola. So with the standard equation, we can do a lot of things. We can find things like the vertex, the axis of symmetry, and the point, the focus, and the line, the directrix. But the only way we can do this is if our equation is in standard form. So that brings me to the question, how would I tackle graphing an equation that looks something like this? So this is a parabola, I'm telling you that right now, but it's not in standard form. So before we can do all our math fun in finding things to graph, we're going to have to change this equation into standard form. So the best way to do this is to just kind of look at standard form and see how we can mirror that here. For example, one thing I noticed is that the x's are on the left and the y's are on the right. So here I probably want to have the x's on the left and move on over the y to the right. That should be a -5 if I move it over. Okay, so the reason I kept only things with an x here is because we know we want our equation to look like a binomial squared. And if I had x squared plus 6x plus 5, we can't factor that. So we need to move that 5 over. So on the left side, we can create something that's factorable. So how do we create something that's factorable? And at the end looks like a binomial squared. Hopefully you're all thinking complete the square, because that's exactly what we're going to do here. Now, I'm not going to spend a lot of time reviewing complete the square. If it's something you do not remember, take a look at my website for an instructional video on how to do that. We want to create a perfect square trinomial, so we can take our half of b and square it and fill in our blank here to get the binomial x squared plus 6x plus 9. Okay, well, whatever you do to one side, adding this 9 in your blank, you'll have to do to the other as well. So if we simplify the right-hand side, we should get -4y plus 4. So the reason that this was helpful is now this becomes a binomial squared. It's really just x plus 3 squared. And it looks a little bit more like standard form. One of the only differences is that in standard form our y is isolated. So I'm going to go ahead and isolate my y here by factoring out whatever is bothering the y, which happens to be -4. So what's left over would be y and -1. A negative times a negative gives us that positive. So congratulations, you very quickly completed the square to get the parabola in its standard form. And the reason this is helpful is because now we can find all of the features in the graph that will help us graph this conic section. So with that said, let's take a look at standard form in our equation and start by finding the vertex. Okay, so remember that this is our h value and this is our k value. And in our standard form, they're being subtracted here. So in order to subtract and get a positive here, we'd have to subtract a -3. So remember what lies inside lies to you. Our vertex x coordinates mean -3. And then y minus k is our standard form. So that means in order to get -k, our y value would be 1. Axis of symmetry then, I think it might be helpful to graph something and kind of figure out what our axis of symmetry is. So let's graph our vertex is at, let's see, -3, +1. So our parabola might look something like this. Now I don't really know yet, but I know my vertex, so I'm just going to think about it for a second. The axis of symmetry is going to go through the vertex and make our parabola symmetrical. So everywhere on this line, as I go up and down, the y values are changing, but the x is what remains consistent. So if it's a vertical line, it's always an x equals equation, and our x equals whatever the point on the vertex it goes through is. So every x value on here is -3. Okay, the focus and directrix are what's new for today. So in order to figure out where the focus and the directrix are, now I'm just drawing a general focus and directrix to kind of talk about it. Not that this is exactly where it is, but we'll find it in a second. But in order to find the focus and directrix, I need to know how far away is the focus from the vertex and the directrix from the vertex. Okay, those distances should be the same. So with that said, if you go back to our standard form, Remember that P is the distance from, that should say from, not form, sorry about that, the focus and directrix. Okay, so whatever our p-value is the coefficient in front of the y minus k. Okay, so this -4 is equal to 4p. Okay, so that's not our p-value yet. It's 4 times p, but we can solve for p given this equality. Okay, so if we divide both sides by 4, we get that p is -1. So with that said, our focus and directrix are -1 units away. What does that mean? Well, let's try and find our focus, and maybe this will help us. Okay, so our focus has the same x-coordinate because it's in line with our vertex, so it's going to be -3. But what the -1 tells us is that our focus is shifted down 1 unit. So our vertex is at 1. That means our focus will be 1 lower. So our focus y-coordinate is really 1 minus 1, which will be at 0. Now I'm thinking about what I drew here, and what does this negative mean? If my focus is actually, and I will erase what I drew for a second, if our focus is actually down 1 unit, so our focus is right here, how is that possible? Because isn't our focus supposed to be inside the parabola? What this distance tells us is actually that our parabola is faced upside down or reflected over the x-axis because our focus is always inside the parabola. So this p distance is actually very important to determining the shape of your parabola. Okay, and I actually went ahead and graphed this equation on Desmos to just kind of get a visual and show you that I'm not crazy. So this was our standard form. I know I factored or completed the square correctly because I got the right vertex as -3, 1, and it's facing downward because our p distance is negative. So our picture should look more like this than what I originally drew. Sorry for tricking you for a second, but I just want to show you how that p-value is super important. Okay, so if our focus is -1 units away from the vertex, our directrix is going to be the opposite direction. So our directrix will be somewhere up here. So with that said, our directrix is a horizontal line, so the x values are changing, but the y value stays the same. And that y value is not at 1 anymore because it shifted 1 unit away because our p distance is 1. But this time it's gone up 1. So from 1, we actually go to y equals 2 is this line here. So by completing the square, we will be able to write the equation of a parabola in standard form and use this equation to graph and find important information of a parabola. Some things to note. In general, the focus always has the same x value, which we call h, as our vertex, but our k value is always shifted up or down by your p distance. So we always add p. In this case, p is negative, so it winds up getting smaller. In general, our directrix is always a y equals equation, because our y is always consistent, but you're going to take whatever your original k value was and subtract the distance. So our original y value was 1, but we had to subtract our p distance, which was -1, so we got 2. So these are general forms of the vertex. I know I applied it to example, but sometimes I think it's easier to work with numbers, or we'd have x equals h. And you have all the standard, you have an example, you should be able to go and complete any problem, no matter what form it's in. So good luck with that, and I will see you later. Have a good night. Bye-bye.